Far beyond the rolling mountains and wide oceans of Earth lies a grand cosmic neighborhood, the solar system. It is a place filled with blazing light, icy shadows, giant storms, and worlds that could never be more different from each other. At the center of this vast community burns the sun, a colossal star of fire and light. Its golden rays reach out like long, invisible arms, holding everything close in a graceful dance. Planets, moons, comets, and countless pieces of rock and ice all move in endless orbits around it, bound by an invisible force we call gravity. The solar system is more than just a collection of planets, it is a story of family. The sun is like a guiding parent, giving warmth and energy. The planets are its children, each with their own personalities and secrets, some small and rocky, some enormous and stormy, and some frozen and distant. Beyond the planets lies a frontier of mystery, belts of icy bodies, clouds of comets, and the unknown depths of interstellar space. Here, our neighborhood meets the rest of the galaxy, and beyond that, the universe itself. This is the story of the solar system, of how it was born from a swirling cloud of dust and gas, of the worlds that circle the sun, and of the endless journey of discovery that humankind continues to make. Imagine standing on the deck of a ship adrift in space. All around you is darkness, vast, silent, and infinite. But ahead, glowing like a golden furnace, is the sun. It dominates the sky, so bright that you cannot look at it directly. Its light pours outward in every direction, filling the void with warmth and brilliance. Every planet, every moon, every drifting stone in the solar system owes its place to this star. Without it, there would be no Earth, no oceans, no forests, no people to wonder at the sky. The sun is not just another object in space. It is the heart of the system, the life giver, the ancient fire that burns steadily in the night of the galaxy. Yet the sun was not always there. Long before it began to shine, there was only a dark cloud drifting through one of the spiral arms of the Milky Way. It was a cloud of hydrogen and dust, enriched by the ashes of older stars that had died in explosions called supernovae. For millions of years, the cloud wandered quietly, until one day it began to collapse. Perhaps the shock wave from a nearby dying star rattled it. Perhaps gravity, slow and patient, simply pulled it together until it could no longer resist. Whatever the cause, the cloud began to spin, flattening into a disk. At the center, matter piled up until the pressure grew unbearable. Atoms of hydrogen were squeezed so tightly that they fused into helium, releasing energy. With that spark, the sun was born, about 4.6 billion years ago. From the beginning, the sun commanded attention. Its gravity held the newborn solar system together. The disk of gas and dust around it gradually clumped into planets, moons, asteroids, and comets. But even as these worlds took shape, they were secondary characters. The sun was the true actor, burning with an energy that dwarfed everything else. And that fire was no ordinary fire. On Earth, fire consumes fuel and dies. The sun's fire is different, fed by the strange, invisible power of nuclear fusion. Deep in its core, temperatures soar to 15 million degrees Celsius. The pressure is so immense that hydrogen atoms cannot resist. They merge together, forming helium and releasing enormous amounts of energy. Every second, hundreds of millions of tons of hydrogen vanish into helium, and in that instant the sun releases enough energy to outshine trillions of light bulbs. And yet it does so calmly, rhythmically, as if breathing. The light born in the core does not escape quickly. A single photon may bounce around for hundreds of thousands of years before finally reaching the surface. It collides, scatters, and is absorbed, only to be re-emitted again, zigzagging slowly outward. Eventually, some of these photons reach the photosphere, the layer we see as the sun's surface. From there, they break free, streaming across space at the speed of light. 8 minutes later, some of them touch Earth, warming skin, brightening skies, and driving the energy cycles of life. The sunlight you see when you step outside began its journey long before humans even existed. Every sunrise is the final chapter of an unimaginably long story that started deep inside the sun's heart. But the sun is more than a light bulb in the sky. Its surface seethes with activity. Through telescopes, astronomers see dark patches called sunspots, cooler regions created by tangled magnetic fields. Sometimes, those fields snap and release bursts of energy called solar flares. At other times, entire loops of plasma arc into space, carried by the sun's magnetic grip. These eruptions can be so powerful that they launch charged particles across the solar system. When these particles strike Earth's magnetic field, they set the skies alight with auroras, shimmering curtains of green and red that ripple near the poles. The same storms can disrupt satellites, power grids, and radio signals, a reminder that our lives are tied to the moods of the sun. The sun also breathes. It exhales a steady stream of charged particles called the solar wind. This wind never stops, it flows in every direction, stretching far beyond Pluto, carving out a bubble in space called the heliosphere. Inside this bubble, the sun's influence is supreme, shielding the planets from some of the galaxy's harshest radiation. Outside lies interstellar space, where the influence of other stars begins. In this sense, the sun is not just the heart of the solar system but its guardian, surrounding us in an invisible cocoon of protection. To the naked eye, the sun seems constant, reliable, eternal. But up close, it is restless. Its surface boils like water in a pot, rising and sinking in giant currents called convection cells. Magnetic fields twist and snap, releasing sudden outbursts of energy. Above the surface, the sun's outer atmosphere, the corona, burns hotter than the layers below, reaching millions of degrees. Scientists still puzzle over why this is so. The corona is usually invisible in daylight, but during a total solar eclipse, when the moon passes in front of the sun, it appears as a ghostly halo stretching outward into space. To ancient peoples, this glowing crown seemed like a glimpse of the divine. For thousands of years, people have looked to the sun with awe. To Egyptians, it was Ra, a god who sailed across the sky each day in a golden boat and descended to the underworld each night. To the Aztecs, it was Huitzilopochtli, a warrior who demanded offerings of blood to keep the universe alive. In Japan, it was Amaterasu, the radiant goddess whose light gave life to the world. Stone monuments like Stonehenge in England and temples in Central America were built to mark the sun's path, its rising and setting, its solstices and equinoxes. Even in cultures that did not personify the sun as a god, it was treated as sacred, the source of time and rhythm, the divider of day and night, the ruler of the seasons. Only recently in human history did we begin to understand the sun scientifically. The invention of telescopes revealed sunspots. Careful observations showed that the number of spots waxed and waned in a cycle of about 11 years. We now know this is caused by the sun's magnetic field flipping, twisting, and resetting itself. At the peak of this cycle, the sun is most active, spitting out flares and storms. At its quietest, the surface is calmer, with fewer spots. These cycles can influence Earth's climate. Centuries ago, a long lull in sunspot activity coincided with the Little Ice Age, when Europe endured colder winters. Even today, space agencies monitor the sun closely, because its storms can interfere with technology we rely on every day. The sun's influence on Earth is profound. It drives the weather, evaporating water into clouds and stirring winds. It fuels photosynthesis in plants, which in turn feed animals and people. The balance of its heat keeps Earth habitable, not too hot, not too cold. Astronomers call this the habitable zone, the region around a star where liquid water can exist. On Earth, life thrives because we are just the right distance away. Venus, closer to the Sun, became a scorching greenhouse. Mars, farther away, froze into a desert. Earth's position, combined with the Sun's steady output, made it a cradle of life. Yet the Sun is not perfectly steady. Over millions of years, its brightness has gradually increased. When life first began on Earth, the Sun was dimmer, and the young planet may have relied on greenhouse gases to stay warm. Now the Sun is brighter, and in the distant future, it will become brighter still. In about 1 billion years, the increasing heat will boil away Earth's oceans, leaving behind a dry, barren world. For all its generosity, the Sun cannot sustain Earth's habitability forever. In the still more distant future, the Sun's changes will be dramatic. When the hydrogen in its core runs low, the Sun will swell into a red giant. Its outer layers will expand, possibly swallowing Mercury and Venus, perhaps even Earth. The sky will be filled with the Sun's enormous disk, glowing red and orange, a terrible and beautiful sight. Eventually, the outer layers will drift away, forming a glowing shell of gas called a planetary nebula. At the center, the core will shrink into a white dwarf, a small, dense star no larger than Earth, but with the mass of the Sun packed inside. For billions of years, it will glow faintly, slowly cooling into darkness. This fate is not unique to the Sun. It is the destiny of all stars of its size. The Sun is an ordinary star, one among hundreds of billions in the Milky Way. Yet to us it is extraordinary, because it is ours. It is the star that gave us light, warmth, and life. It is the star we see every morning when we open our eyes. It is the reason we exist at all. To think of the Sun's story is to think of our own. We are made of atoms forged long ago in the hearts of stars like it. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were created in stellar furnaces. The Sun, too, carries that heritage, born from the ashes of stars that came before. It shines now in its prime, and we thrive under its light. One day it will fade, and life on Earth will vanish or move elsewhere. But even then, its gift will not be lost. Its dust and gases will seed new stars, new planets, perhaps new forms of life, continuing the cycle. When you stand outside and feel the Sun's warmth on your skin, you are touching energy that has traveled across space, born from a fusion reaction deep in the Sun's heart. When you see plants grow, you are watching sunlight transformed into life. When you see an aurora in the polar skies, you are witnessing the dance of the Sun's particles with Earth's magnetic shield. Every moment of your life is linked to that star. The Sun is not just the heart of the solar system. It is the thread that binds us to the cosmos, a reminder that we live in the light of a star. If you could stand on a ledge somewhere in the depths of space and watch the planets circle the Sun, one world would always be racing ahead of the others. Small, dark, quick, slipping close to the Sun and then darting away again, it would remind you of a silver fish flashing in a stream. This is Mercury, the innermost planet, the smallest of the major worlds, and the swiftest traveler in the solar system. For as long as people have watched the heavens, Mercury has been difficult to catch. To ancient eyes it seemed to dart close to the horizon just before sunrise or just after sunset, always vanishing in the sun's glare. Sometimes it was seen in the evening sky, sometimes in the morning, leading some early cultures to believe they were looking at two different stars. Only with patient observation did they realize it was a single wanderer, forever tied to the sun. The Romans named it after their messenger god, Mercury, whose winged sandals carried him swiftly across the world. The name is fitting. Mercury circles the sun in just 88 Earth days, making it the fastest of all planets. But speed is not the only thing that sets Mercury apart. To imagine what it would be like to visit this world, picture a place where the sun looms more than twice as large in the sky as it does from Earth, blazing with a heat so fierce it could melt lead. At noon, the surface scorches at over 400 degrees Celsius, hot enough to cook metal. Yet once the sun slips below the horizon, the warmth vanishes. With no thick atmosphere to hold the heat, temperatures plunge to nearly minus 180 degrees Celsius. The same rocks that baked in unbearable heat by day are frozen in brutal cold by night. It is a world of extremes, a planet of fire and ice locked in silence. That silence is one of Mercury's most haunting qualities. Unlike Earth, it has no blanket of air to carry sound, no clouds to drift across the sky, no winds to stir the dust. If you stood on its surface, you would hear nothing, not even your own breath unless it echoed inside your helmet. The sky would be black even in daylight, stars twinkling beside the sun. Your footprints would remain unchanged for centuries, perhaps millennia, because there is nothing to erase them. Mercury is a world frozen in time, a relic of the solar system's earliest days. Its face tells that story. Seen up close by spacecraft, Mercury looks much like our moon, cratered, pocked, and scarred by ancient collisions. There are craters of every size, from tiny pinpricks to vast basins hundreds of kilometers wide. The largest of them, the Colossal Basin, is an enormous wound over 1,500 kilometers across, the scar of a colossal impact billions of years ago. When the asteroid struck, it released so much energy that the crust rippled like water, leaving strange jumbled hills on the opposite side of the planet. Elsewhere, great cliffs, some stretching for hundreds of kilometers, cut across the surface. These cliffs, called scarps, formed as Mercury's interior cooled and shrank. The whole planet literally contracted as it aged, wrinkling its crust like the skin of a dried fruit. Yet Mercury is not merely a smaller copy of the Moon. Hidden beneath its battered surface is a secret, an enormous metallic heart. Mercury's iron core is proportionally far larger than Earth's, taking up most of its interior. It makes the planet unusually dense, second only to Earth in the entire solar system. Why does such a small planet carry such a heavy burden of metal? Some scientists think that long ago Mercury may have been larger, with a thick mantle of rock like the other planets. Then a gigantic collision might have stripped away much of that outer shell, leaving behind the dense core we see today. Others believe the heat of the newborn sun burned away the lighter materials. However it happened, the result is striking. Mercury is, in a sense, all heart. That heart still beats faintly. Despite its small size and ancient age, Mercury possesses a magnetic field, weak but real. This is unusual for a planet so small, since magnetic fields are usually generated by liquid metal churning inside a planet's core, and smaller planets tend to cool and solidify quickly. Mercury's field hints that at least part of its core remains molten, defying expectations. This discovery came from spacecraft that dared to visit this elusive world, bringing back not just pictures but surprises. Visiting Mercury is no easy task. Its closeness to the sun makes it difficult to reach. Spacecraft must fight against the pull of the sun's gravity, slowing themselves down rather than speeding up, which is counterintuitive in space travel. The first visitor was Mariner 10, which flew past Mercury 3 times in the mid-1970s, capturing the first close-up images of its cratered surface. For decades after, Mercury was left alone, a forgotten world. Then, in 2004, NASA launched the Messenger spacecraft, which finally entered orbit around Mercury in 2011. Over the next 4 years, Messenger mapped the planet in detail, measured its magnetic field, and revealed features never before seen. Among its discoveries were surprising hints of water ice hidden in craters near the poles, places so deeply shadowed that sunlight never reaches them. Even on this scorched planet, cold traps preserve frozen water, delivered long ago by comets and asteroids. The contrast is breathtaking, a world where daytime heat can melt lead, yet in eternal shadows, ice survives. Now a new mission, Colombo, launched by Europe and Japan, is on its long journey to Mercury, scheduled to arrive in the 2030s. It carries with it new instruments to probe the planet's mysteries. Why does it have such a large core? How does its thin, fragile magnetic field work? What does its surface reveal about the earliest days of the solar system? Each mission peels back another layer, showing that even the smallest planet can hold great secrets. Mercury's orbit adds to its strangeness. It circles the Sun so quickly that a year on Mercury lasts only 88 Earth days. But its rotation, the time it takes to spin once on its axis, creates an unusual rhythm. Mercury rotates 3 times for every 2 orbits around the Sun, a dance known as spin-orbit resonance. This means that if you stood on the surface, a single day from sunrise to sunrise would last 176 Earth days, 2 full Mercurian years. The Sun would rise slowly, crawl across the sky, and set after weeks of daylight. In some places, because of the way the orbit and rotation interact, the Sun would appear to rise, pause, reverse direction briefly, and then continue its climb. Time on Mercury is a slow, strange march. For ancient cultures, Mercury's fleeting appearances in the twilight sky inspired both curiosity and mystery. To the Greeks it was Hermes, the quick-footed messenger who darted between realms. To the Babylonians it was Nabu, the god of wisdom and writing. To the Maya, its shifting presence was woven into stories of cycles and balance. Its dual identity, sometimes seen in the morning, sometimes in the evening, made it a symbol of change, transition, and communication. Even today, when astronomers speak of a planet being in Mercury retrograde, they are drawing on an ancient observation of the planet's apparent backward motion against the stars, a trick of perspective caused by Earth overtaking Mercury in its orbit. Yet beyond myths, Mercury has scientific importance. It is a fossil of the early solar system, a world that never grew large or developed thick atmospheres or oceans. By studying it, scientists learn about the processes that shaped the planet's billions of years ago. Its craters preserve a record of impacts, a cosmic diary of the violence that once bombarded all the inner worlds. Its core offers clues about planetary interiors, magnetic fields, and even the conditions of the Sun's early activity. And its extremes of heat and cold, its ice-enshadowed craters, teach us how materials survive in hostile environments. What of Mercury's future? In billions of years, as the Sun grows hotter and swells into a red giant, Mercury will be the first planet to face destruction. Its orbit may shift, perhaps even destabilize, as the Sun loses mass and its gravity weakens. Some simulations suggest Mercury could be swallowed whole by the expanding star. Others suggest it might be thrown outward, surviving as a wandering ember. Whatever happens, Mercury's story is tied intimately to the Sun's fate. The smallest planet is also the most vulnerable, forever at the mercy of the giant it circles. Yet for now, Mercury endures. It continues its rapid orbit, a scarred survivor of cosmic violence, a silent messenger at the edge of the Sun's blazing domain. Though it is small, it commands attention for its swiftness, its resilience, and its secrets. To visit Mercury in imagination is to glimpse the extremes of the solar system, the hottest days, the coldest nights, the deepest silences, the oldest scars. It is a world that has been overlooked for centuries, hidden in the sun's glare, but those who study it know it is a key to understanding the story of all the planets. So next time you stand outside just after sunset or just before dawn, look low on the horizon. If you see a small, bright point of light hovering near the sun, you may be catching a glimpse of Mercury, the fleet-footed world, the smallest of the planets, the swift messenger of the skies. Think of the searing heat on its surface, the frozen darkness in its shadows, the giant cliffs wrinkling its crust, the silent craters preserving the memory of ancient impacts. Think of the spacecraft that have flown past it, revealing its secrets little by little. And think of how this tiny planet, so easy to miss, carries within it the echoes of the solar system's birth. Mercury may be small, but its story is vast, and it whispers to us of beginnings, endurance, and the strange beauty of worlds forever circling the sun. If Mercury is the swift messenger of the solar system, darting close to the sun in silence, then Venus is its luminous jewel, glowing like a lantern in the sky. Of all the planets, none shines as brightly to the human eye as Venus. At dusk or dawn, it appears as a brilliant point of light, often the very first star to emerge as evening falls, or the last to fade at sunrise. For thousands of years, people called it the morning star or the evening star, marveling at its brilliance. Poets wrote of its beauty, and ancient civilizations saw it as a goddess of love, fertility, and desire. The Romans named it after Venus, their goddess of love, while the Greeks called it Aphrodite. To the Maya, it was the great warrior Kukulkan. Across the world, Venus has always commanded both awe and reverence. It is the brightest planet in our skies, so close and so dazzling that for much of history people thought of it almost as a twin of Earth. And in some ways, Venus is Earth's sister. The two worlds are nearly the same size and mass. If you placed them side by side in space, you would see two spheres of nearly equal girth, both wrapped in a blanket of clouds. Venus is the closest planet to Earth, never straying too far in the night sky, and for centuries scientists imagined it might be a second Earth. Early astronomers wondered if jungles grew beneath its clouds, if oceans shimmered in its sunlight, if strange creatures thrived in its humid air. In the 19th and early 20th centuries, some even speculated about swamps, rainforests, or civilizations hidden under the veil of white. Venus seemed mysterious, tantalizing, and promising. But the truth, when revealed by modern science, was both more shocking and more haunting. Beneath the lovely disguise of its bright clouds lies one of the most hostile environments in the solar system. Venus is not a paradise but a furnace, a planet of crushing pressure, boiling heat, and unrelenting storms. If Earth is the jewel of habitability, Venus is its dark mirror, a warning of how a world can turn against life. To stand on Venus, if such a thing were possible, would be to experience something out of a nightmare. The air is not breathable, it is carbon dioxide, thick and suffocating. The pressure is 90 times greater than Earth's sea level, the same as being nearly a kilometer beneath the ocean. It would crush a human instantly. The temperature is over 460 degrees Celsius, hotter even than Mercury's sunlit side, despite Venus being farther from the sun. The heat is enough to melt lead, zinc, and tin. Metals would soften and drip. The ground bakes endlessly under a heavy, choking sky. And that sky is not just carbon dioxide but laced with clouds of sulfuric acid, droplets of poison floating in the air. Lightning crackles through the clouds, and winds at the upper levels whip around the planet at hurricane speeds. This is no gentle twin of Earth. It is a hellscape, a vision of a world gone wrong. Why is Venus like this? The answer lies in its atmosphere. Long ago, Venus may have been more Earth-like. Some scientists believe it once had oceans of liquid water, perhaps for hundreds of millions of years. But Venus is closer to the Sun, receiving more heat. That extra energy may have caused its oceans to evaporate more quickly. Water vapor is a powerful greenhouse gas, trapping heat. As more water evaporated, the air trapped more heat, which caused even more evaporation. A runaway greenhouse effect began, spiraling out of control. The oceans boiled away, leaving behind a thick blanket of carbon dioxide. The planet roasted until it reached the state we see today, a suffocating furnace where liquid water cannot exist. Venus may once have been a world with seas and skies, but it became a warning of climate catastrophe. Despite its hostility, Venus fascinates scientists because it offers a glimpse into planetary evolution and perhaps even Earth's future. Our planet, too, has greenhouse gases in its atmosphere, though in far smaller amounts. Studying Venus helps us understand the delicate balance that makes Earth habitable. It reminds us that planets can change dramatically, that the line between paradise and disaster is thin. The surface of Venus is hidden from view by its thick clouds. For centuries, telescopes revealed only its smooth, featureless veil. Only when radar was used to pierce the clouds did we begin to see what lay beneath. The surface is a landscape of vast plains, towering mountains, and immense volcanoes. Venus is covered with volcanic features more than any other planet. Some volcanoes are shield-like, spreading lava in broad domes, while others rise in steep cones. Enormous lava flows stretch for hundreds of kilometers. Strange circular structures called coronae mark places where hot material has bulged upward from the mantle, cracking and collapsing the crust. The entire planet seems shaped by volcanic fire. Yet Venus is puzzling in another way. Its surface looks geologically young. Craters are relatively few, suggesting that the entire crust may have been resurfaced by massive volcanic activity a few 100 million years ago. It is as though the planet erupted on a global scale, burying its past beneath fresh lava. Whether Venus is still volcanically active today is a mystery, but recent evidence suggests it might be. Changes detected by orbiting spacecraft hint that eruptions could still be shaping its surface, making it one of the few planets besides Earth where volcanoes may still breathe fire. Venus rotates slowly and strangely. A day on Venus, the time it takes to spin once on its axis, lasts 243 Earth days, even longer than its year of 225 Earth days. And it spins backward, in the opposite direction to most planets. On Venus, the sun would rise in the west and set in the east, though it takes so long that the day would stretch endlessly. Its slow, retrograde spin is one of the great mysteries of the solar system. Did a giant collision tip it over? Did tidal interactions with the sun slow and reverse its spin? Whatever the cause, it adds to the planet's sense of strangeness. Despite the brutal conditions, humans have reached the surface of Venus, if only briefly. In the 1970s and 1980s, the Soviet Union's Venera landers descended through the thick atmosphere, their cameras protected against the heat and pressure. They survived only minutes, some less than an hour, before being destroyed by the conditions. But in those precious minutes they sent back the first images of the surface, bleak, rocky plains under a hazy orange sky, stones scattered across a baked landscape. The photographs were haunting, a glimpse of an alien world hidden for all of human history. Later missions, such as NASA's Magellan spacecraft in the 1990s, mapped the planet with radar, revealing its volcanoes, mountains, and plains in detail. Today, new missions are being planned by NASA and ESA to return to Venus, to study its atmosphere, geology, and potential volcanic activity. After decades of neglect in favor of Mars, Venus is once again a target of exploration. For all its hostility, Venus has also inspired dreams. Some scientists imagine floating cities in the upper atmosphere, where conditions are surprisingly mild. About 50 kilometers above the surface, temperatures and pressures are closer to those on Earth, and although the clouds are acidic, technology could protect against them. There, giant balloons or airships could drift in the sky, suspended in a sea of carbon dioxide. Humans might never walk on the burning surface, but perhaps one day they could sail through the skies of Venus, looking down on a world that is forever hidden by its own clouds. Venus has always been a planet of contrasts. To the eye, it is the brightest and most beautiful star-like object in the sky, a symbol of love and desire. To science, it is a furnace of death, a warning of climate disaster. To mythology, it was a goddess, a warrior, a symbol of fertility. To exploration, it is a challenge, a puzzle, a reminder that appearances can deceive. Earth and Venus are sisters, yet one is a paradise and the other a hell. And in that contrast lies perhaps the greatest lesson of all: worlds that look alike can have very different fates. When you see Venus shining at dawn or dusk, think of what lies behind that brilliance. Think of the thick clouds swirling endlessly, of the volcanoes that may still rumble, of the crushing atmosphere and the baking heat. Think of the oceans that may once have shimmered there, long vanished into steam, leaving behind a planet forever changed. Venus is not just a distant world, it is a mirror that reflects what could have been, and what might yet be, if balance is lost. It is the brightest star in our sky, but also the darkest cautionary tale. Venus continues its slow, backward spin, wrapped in its veil of white, dazzling to us and yet unreachable. It is a world of contradictions, of beauty and terror, of mystery and revelation. To study Venus is to study not only a planet but the fragility of planets, the power of atmospheres, and the thin line between habitability and ruin. And as our spacecraft return there in the coming years, we will peel back more of its secrets, learning not just about Venus, but about Earth, and about the destiny of worlds. So when the evening falls and you step outside, look to the west for the first star-like point of light. Or rise before dawn and look east for the last to fade. That shining beacon is Venus, the morning star, the evening star, the sister of Earth, the jewel of the sky. Behind its beauty lies a world of fire and poison, but also of lessons, warnings, and wonder. Venus is both goddess and ghost, a reminder that the cosmos is filled with worlds we cannot yet fully imagine, each with its own story written in stone, cloud, and time. If you were traveling through the solar system and looked back toward the sun, you might see a small blue jewel glimmering in the blackness. It would not be the largest planet, nor the smallest. It would not burn with fire like the sun, nor blaze with brilliance like Venus. And yet, of all the worlds you could pass, this one would stand out. Wrapped in swirls of white cloud, shaded with greens and browns of land, and glowing with the deep blues of ocean, Earth is unmistakable. It is not just another planet. It is a living planet, a world that breathes, shifts, and sings with the sound of countless forms of life. It is our home. To a traveler from afar, Earth would seem enchanted. Against the endless void of space, its colors leap out, vibrant and alive. The air around it forms a delicate halo, thin as breath, glowing faintly in the sunlight. The continents drift like floating rafts across the oceans, reshaped by time. Storms twist in great spirals across its surface, clouds racing above seas that shimmer and reflect. No other planet we know of looks quite like this. Earth is not just a rock circling the sun, it is a complex, dynamic system where land, water, air, and life are bound together in an intricate dance. And yet, Earth is also a planet like any other, forged from the same cosmic ingredients that built Mercury, Venus, and Mars. Around 4.5 billion years ago, when the sun was still young, Earth was nothing more than dust and rock clumping together under gravity's pull. Collisions were frequent, violent, and catastrophic. Smaller bodies crashed into one another, heating and melting as they grew. Eventually, Earth emerged from this chaos as a molten world, its surface a sea of magma. Heavier materials sank toward the center, forming the core, while lighter rocks floated upward, forming the mantle and crust. The planet cooled, hardened, and began to stabilize. Outgassing from volcanoes filled the air with gases, carbon dioxide, water vapor, nitrogen. At first, Earth was no paradise. Its skies were toxic, its surface battered, its seas boiling. Then came an event that changed Earth forever, the giant impact. A body the size of Mars collided with the young Earth, an impact so violent that it hurled vast amounts of debris into space. That debris eventually coalesced into the Moon, Earth's constant companion. The Moon has circled us ever since, shaping tides, stabilizing Earth's tilt, and even influencing the rhythms of life. Without the Moon, Earth would be a very different planet. As the surface cooled and rains fell, oceans formed, filling the lowlands with water. With oceans came climate moderation, a cycle of evaporation and rainfall that continues to this day. Life, tiny, microscopic, fragile, emerged in these waters. The first cells appeared, feeding on sunlight or chemicals, multiplying and evolving. Over billions of years, they transformed the planet. Cyanobacteria released oxygen as waste, slowly filling the atmosphere with this vital gas. The oxygen built up, creating a protective ozone layer and paving the way for more complex life. Plants spread, animals followed, and eventually forests, fish, insects, reptiles, birds, and mammals covered the globe. Life and Earth shaped each other, each transforming the other in ways profound and permanent. Earth's surface is not still, it is restless, alive with motion. Unlike Mercury or the Moon, whose crusts are frozen in place, Earth's crust is broken into plates that drift on the molten mantle beneath. These tectonic plates collide and pull apart, giving rise to mountains, valleys, earthquakes, and volcanoes. The Himalayas rise where India collides with Asia. The Pacific Ring of Fire marks places where plates dive beneath one another, fueling eruptions. Continents themselves drift, reshaping the face of the planet over hundreds of millions of years. What we call solid land is in fact fluid across the vast scales of time. The oceans are equally dynamic. They cover over 70% of Earth's surface, circulating heat and nutrients across the globe. Ocean currents regulate climate, carrying warm water from the equator toward the poles and cold water back again. The Gulf Stream warms Europe, the Antarctic circumpolar current isolates the icy continent. Life thrives in these waters, from tiny plankton to the largest animals ever known, the blue whales. The oceans are the heart of Earth's climate engine, and they are also its great cradle of life. Above the land and sea lies the atmosphere, a thin shell that sustains everything we know. It is only about 100 kilometers thick before blending into space, yet without it, Earth would be barren. The atmosphere shields us from meteors, burns away harmful radiation, and keeps temperatures stable. It carries winds and rains, creates storms and seasons, and sustains the water cycle that nourishes life. Breathing it in feels natural to us, but it is a rare gift in the cosmos. Our air, mostly nitrogen, oxygen, and trace gases, is not something found easily elsewhere. Venus has an atmosphere, but it smothers its world in carbon dioxide and sulfuric acid. Mars has one, but it is thin and weak, offering little protection. Earth's atmosphere is tuned, balanced, alive with chemistry, shaped not just by physics but by life itself. Life and Earth are inseparable. Plants breathe in carbon dioxide and release oxygen. Animals breathe oxygen and exhale carbon dioxide. Forests and oceans store and release gases, moderating climate. Microbes recycle nutrients in soil and sea. Coral reefs build structures that host entire ecosystems. Over billions of years, life has altered the land, carved out rivers, and even changed the color of the sky. Earth without life would be a different planet entirely, colder, harsher, less vibrant. Earth's beauty is visible even from space. Astronauts who have looked back at the planet describe an overwhelming sense of wonder. They see the thin blue line of the atmosphere, the swirling white clouds, the continents stretched below. They call it the overview effect, the realization that our world is both vast and fragile, a single, shared home. From space, there are no borders, no nations, only the curve of a planet glowing against the black. Yet Earth is not invulnerable. Its climate is delicate, and its systems interwoven. Human activity has begun to change these systems in noticeable ways. Burning fossil fuels releases greenhouse gases, warming the atmosphere. Forests are cut down, oceans acidify, species vanish. Just as Venus once experienced a runaway greenhouse effect, Earth, too, faces the risk of destabilizing its climate. We live on a planet that is uniquely suited to life, but its balance depends on choices made by its inhabitants. The story of Earth is not only geological and biological, it is also cultural and ethical. Humanity has become a force capable of altering the planet itself. The Anthropocene, as some call it, is a new chapter in Earth's long history, one where the fate of life depends on the actions of a single species. Still, Earth endures, resilient and dynamic. Its continents shift, its oceans churn, its skies change with the seasons. Each dawn paints the land in color, each sunset glows with fire. Rain falls, rivers carve valleys, mountains rise, glaciers creep, forests grow, deserts expand. Earth is in motion, always changing, always renewing. And life, with its endless creativity, adapts, evolves, and thrives. To compare Earth to its neighbors is to appreciate its uniqueness. Mercury is barren, Venus is suffocating, Mars is cold and dry. Jupiter, Saturn, Uranus, Neptune are gas giants, inhospitable and stormy. Among all the planets, Earth alone wears oceans of liquid water and skies of breathable air. Earth alone is alive, vibrant, fertile. It is not only the third planet from the Sun but the heart of the story we tell about worlds. The Moon, our companion, circles Earth faithfully, raising tides that shape coastlines and stir the seas. The Sun warms the planet, driving winds, currents, and seasons. The tilt of Earth's axis creates cycles of light and dark, growth and rest. From the smallest insect to the tallest mountain, from the deepest trench to the highest cloud, Earth is interconnected. Each part influences the other, forming what scientists call the biosphere, a thin, delicate layer where life flourishes. If we think of planets as characters, Earth is both mother and child. Mother, because it has given birth to countless forms of life; child, because it was born from the dust of stars, nurtured by the sun, shaped by cosmic collisions. Its story is long and complex, filled with catastrophes and recoveries, extinctions and explosions of diversity. Dinosaurs ruled for millions of years, then vanished in the blink of an eye, paving the way for mammals. Ice ages froze vast continents, then melted, allowing forests to spread. Each chapter of Earth's history has been written in stone, ice, and fossil, a record of a planet that has never stopped changing. And here we are, one species among millions, telling the story of our world. We are the only creatures we know of who can look up at the stars, see Earth as a planet, and wonder about its place in the cosmos. We build spacecraft, send probes to other worlds, and dream of settling beyond Earth. But wherever we go, we carry with us the memory of blue skies, green fields, and the sound of waves on a shore. Earth is not just our home, it is the measure by which we understand all other worlds. One day, far in the future, Earth's story will end. The sun will grow hotter, oceans will evaporate, and life as we know it will fade. Eventually, billions of years from now, the sun will expand into a red giant, and Earth may be swallowed whole. But for now, in this fleeting moment of cosmic time, Earth thrives. It spins beneath the sun, wrapped in its thin shell of air, alive with forests, seas, deserts, and cities. It carries the songs of birds, the migrations of whales, the footsteps of people. It is not just a planet, it is a miracle of balance and complexity. So when you look at Earth, whether from a mountain peak, a city street, or a photograph taken from space, remember that it is rare and precious. Remember that in all the vastness of space, no other world yet known carries the richness and beauty of this one. Earth is our cradle, our companion, our challenge, and our story. It is the blue jewel of the solar system, unique among its siblings, and for us, it is everything. For as long as humans have looked up at the night sky, there has been one star-like light that seemed different from all the rest. It was not the brightest, nor the largest to our eyes, but it glowed with a faint, rusty tint, like a burning coal cooling at the edges. Ancient skywatchers noticed that while most stars stayed fixed in their patterns, this red light wandered. It shifted against the backdrop of constellations, moving steadily as though it had a path of its own. The Greeks called such lights planets, meaning wanderers, and this particular wanderer was given a name inspired by its color and temperament, Mars, the god of war. To the Romans, that reddish hue was the shade of blood, of iron, of battlefields. For thousands of years, whenever people looked up and saw Mars, they imagined warriors, conflict, and raw power. But the story of Mars is far larger than myths of war. It is a tale that stretches from dusty temples where astronomers scratched symbols into clay tablets to gleaming laboratories where rovers beam back photographs across millions of kilometers. It is the story of a small world that has captured our imagination more than any other. To talk about Mars is to talk about curiosity itself, the human drive to reach beyond what we can touch, to see what lies in the next valley, the next ocean, or the next planet over. Imagine standing on a hilltop on Earth long ago, thousands of years before telescopes. The air is cool, the sky dark, and above you is a canvas of stars so thick it looks as if someone spilled a jar of glowing sand. You spot Mars, brighter than most, tinged red, and you wonder, what is it? Is it a god? Is it a fiery lantern? Could it be a world like ours? For early humans, Mars was mystery incarnate. Egyptians associated it with Horus, the god of the sky. Babylonians tracked its movements, calculating its cycle through the heavens. The Chinese called it the fire star, tying it to omens and fortune. Across cultures, Mars was never just another point of light, it was a message in the sky. Centuries passed, and curiosity grew sharper. By the time of the Renaissance, when telescopes began to reveal more detail than the naked eye ever could, Mars became more than a symbol. In the 1600s, the Dutch astronomer Christian Huygens sketched a dark blotch on Mars' surface, Syrtis Major, and noticed a polar cap. Suddenly, Mars wasn't just a red dot, it was a world with features, with geography, with something that might change with the seasons. Then came Giovanni Schiaparelli in the late 1800s, who drew long, straight lines across Mars, calling them canali, meaning channels. English-speaking readers, mistranslating, believed he meant canals, artificial waterways. Almost overnight, newspapers and scientists alike speculated that intelligent Martians had built them to survive on a drying world. This idea took root in the imagination like wildfire. Percival Lowell, a wealthy astronomer in the United States, built an observatory in Arizona just to study Mars. Night after night he peered through his telescope and convinced himself he could see the canals crisscrossing the planet. He wrote passionate books about an advanced Martian civilization fighting to preserve their world by building vast waterworks. People read his words and believed. Soon, Mars wasn't just a neighbor in the sky, it was a place alive with possibility. Science fiction writers like H.G. Wells fueled the fire. In his novel The War of the Worlds, Martians invade Earth, fleeing their own dying planet, bringing terror and destruction. For readers in the 19th and early 20th centuries, Mars was alive in the collective mind. It was the planet of neighbors, whether friendly or hostile. But dreams often clash with reality. As technology advanced, telescopes improved, and spacecraft were invented, humans got closer looks at the red planet. In the 1960s, NASA's Mariner missions flew by Mars, snapping the first close-up pictures. The results shocked the world. No sprawling cities, no canals, no gleaming towers of alien technology. Instead, Mars looked desolate, dusty plains, craters, barren ridges. Some were disappointed, but others were fascinated. Because while it was empty of civilizations, it was also beautiful, strange, and unlike anything we'd seen before. The dream of Martians faded, but a new dream rose, perhaps not civilizations, but maybe, just maybe, life in simpler forms. Bacteria, fossils, traces of water. And beyond that, could Mars someday be a home for us? To understand why Mars matters so much, we need to picture what it is really like. Imagine traveling through space on a ship, millions of kilometers from Earth. Days blur into weeks. You watch the blue dot of home shrink behind you until it is no brighter than a star. Ahead, Mars grows steadily larger, its rusty surface turning from a smear into a globe. Finally, you arrive. Through the porthole, you see a world wrapped in dust. Its sky is tinted butterscotch, and its ground is the color of iron rust. Volcanoes taller than Mount Everest rise on the horizon, and canyons wider than the entire United States cut across the land. Mars is about half the size of Earth, with weaker gravity, just 1/3 of what we feel here. That means you could jump higher, carry heavier loads, and run in great bounding strides. But don't be fooled, its air is not our air. The atmosphere of Mars is thin, less than 1% of Earth's pressure, and made mostly of carbon dioxide. Without a suit, you could not breathe. Without protection, the cold would freeze you, the average temperature hovers far below zero. Dust storms can rage across the whole planet, blotting out sunlight for weeks. Yet despite all this harshness, Mars whispers to us of familiarity. It has seasons. It has polar ice caps. It has landscapes that resemble deserts on Earth. It feels like a cousin, a world that could, with enough effort, host us. Scientists have uncovered clues that Mars was not always this way. Billions of years ago, it seems Mars had rivers, lakes, maybe even an ocean. Channels carved in rock suggest water once flowed freely. Minerals that only form in water have been found. If Mars had water, could it have had life? And if it once did, what happened to it? Did Mars dry out because it lost its magnetic field, letting solar winds strip away its atmosphere? Was it once a vibrant world that turned into a desert? These questions drive our missions today. In the late 20th century and into the 21st, we began sending robotic explorers, each one a scout for humanity. The Viking landers of the 1970s touched down and tested the soil for signs of life. They didn't find any, but they taught us how to survive there. Decades later, Spirit and Opportunity rovers roamed the dusty plains, lasting years longer than expected, sending back panoramas of a hauntingly beautiful world. Curiosity, a nuclear-powered rover, still explores Mars today, drilling rocks, analyzing chemistry, searching for traces of organics. Perseverance, its younger sibling, now rolls through Jezero Crater, an ancient river delta, hunting for signs of past microbes. It even carries a tiny helicopter, Ingenuity, which became the first aircraft to fly on another planet. Each rover is like a mechanical pioneer, a stand-in for the footsteps we have not yet taken ourselves. Yet behind these machines lies a human longing. For young adults today, Mars is more than a scientific curiosity, it is a frontier. It is the place we dream of setting foot on, of planting bases, of building habitats beneath domes or underground lava tubes. Entrepreneurs like Elon Musk speak of fleets of ships carrying colonists to Mars, of cities glowing under glass skies, of a multiplanetary humanity. Space agencies plan step by step, from moon bases to Mars missions, from testing survival systems to training astronauts for years of isolation. The dream is not just to visit, but to stay. To carve out a second home among the stars. But it won't be easy. Imagine life as the first Martian settler. You wake inside a pressurized habitat, metal walls protecting you from deadly air outside. Every sip of water, every breath of oxygen, every calorie of food has been recycled, grown, or transported at immense cost. A walk outside means donning a bulky suit, careful checks, constant awareness. The nearest help is millions of kilometers away, with communication delayed by minutes. There is no margin for error. Mars would demand from us discipline, resilience, cooperation. Yet it would also offer wonder, to step outside and see two tiny moons, Phobos and Deimos, hanging in the sky, to watch a sunset that fades from blue to orange instead of orange to blue, to stand at the edge of Valles Marineris and know you are looking into a canyon deeper than imagination. Mars is not only about survival, it is about meaning. Why go at all? Some say it is insurance for humanity, a backup in case Earth suffers catastrophe. Others say it is the next natural step in exploration, just as our ancestors crossed oceans. Many feel it is about inspiration, the sheer audacity of reaching another planet. For young people, Mars represents a dream bigger than any one life. To know that humans could walk there within your lifetime is to know you live in an age of epic possibility. Of course, Mars also forces us to reflect on Earth. When we study Mars' climate, we learn lessons about our own. Mars is a frozen desert partly because it lost its greenhouse effect. Earth, meanwhile, wrestles with too much of one. Mars reminds us that worlds are fragile. It shows us what happens when atmospheres are stripped, when water disappears, when protection fades. To dream of terraforming Mars, warming it, thickening its air, melting its ice, is also to realize how delicate and precious our own planet's balance is. Yet imagination has always been Mars' greatest gift. Writers, filmmakers, and artists have used it as a canvas for hopes and fears. In one story, it is a utopia of new beginnings. In another, it is a hostile desert demanding sacrifice. Sometimes Mars is a mirror for our anxieties about colonialism, survival, the unknown. Sometimes it is a stage for our boldest ideas, where humans grow potatoes in Martian soil, where explorers uncover alien ruins, where pioneers carve a new society. For every rover picture that shows us reality, there are 1,000 stories that paint Mars in the colors of possibility. So where are we now? We stand at the edge of a new chapter. In the coming decades, humans may finally walk on Mars. It will be one of the hardest things we have ever done. The journey itself will take months. The landing will be risky, the thin atmosphere makes parachutes less effective, rockets more necessary. The surface will test us with dust storms, radiation, cold. But the prize is extraordinary, to look back at Earth as a small dot, to leave footprints on another world, to prove that humanity's story is not bound to one planet. Think of it this way: thousands of years ago, someone first dared to sail beyond sight of land, into seas that seemed endless. Their friends and family must have thought them reckless, foolish, perhaps doomed. Yet because of them, continents were discovered, connections forged, horizons expanded. Today, Mars is our ocean. Its dusty plains are the distant shores we yearn to touch. And young people alive right now may be the ones who make it happen, not only astronauts, but engineers, scientists, writers, dreamers, all contributing to the great endeavor. Mars is no longer just the god of war, no longer just a dot of red light. It is a place, real and tangible, waiting in the night sky. It is our neighbor, our challenge, our dream. It has inspired myths, sparked fears, taught science, and now calls us to adventure. When you next look up and see it shining faintly, remember, that is not just a star. It is a world we are learning to know, a world that could one day echo with our voices, our laughter, our stories. And perhaps, centuries from now, children on Mars will look up at their night sky, see a tiny blue dot, and wonder about the world their ancestors once called home. Mars is the story of humanity itself, of curiosity that refuses to rest, of imagination that refuses to die, of courage that refuses to stop at boundaries. It is a reminder that even in the cold silence of space, we carry the fire of exploration. And as long as that fire burns, Mars will not be just the red planet. It will be the next chapter in the great human story. Between the familiar orbits of Mars and Jupiter lies a realm that is neither fully empty nor fully crowded. It is not a planet, though it contains the fragments of one that might have been. It is not a calm, polished system like Earth's neighborhood, but rather a scattered, chaotic region filled with rocky wanderers. This is the asteroid belt, the solar system's rocky frontier, a place of fragments, mysteries, and echoes of ancient time. Imagine you are flying outward from the sun. You pass Mercury, scorched and barren, then Venus, shrouded in its golden clouds. Earth comes next, blue and vibrant, followed by red, dusty Mars. If you expected Jupiter to be next, you would be surprised. Before reaching the gas giant, you enter a wide zone, millions of kilometers across, populated not by one great world, but by countless small ones. This is the asteroid belt, a cosmic puzzle where the pieces never quite fit together. The story of the asteroid belt begins at the dawn of the solar system, 4.5 billion years ago. Back then, the sun was young, surrounded by a swirling disk of gas and dust. Within that disk, tiny particles clumped together, forming pebbles, then rocks, then planetesimals. Some of these grew into planets: Mercury, Venus, Earth, Mars. Beyond the frost line, where ices could survive, giants like Jupiter and Saturn formed. But between Mars and Jupiter, something went wrong. The building blocks were there, ready to combine, yet no planet ever emerged. Instead, the region froze in an unfinished state, its rocks locked in endless orbits. Why? The answer lies with Jupiter. The giant planet's immense gravity stirred the region, tugging at would-be worlds, breaking apart their orbits. Any large object that tried to grow there was pulled, stretched, and eventually destroyed. Jupiter's influence prevented the rocks from merging into a single planet. Instead, they remained as fragments, asteroids. In this way, the asteroid belt is a place of interrupted destiny, a planet that never was. But do not picture it as a dense swarm where spacecraft must dodge constantly, like in science fiction movies. In reality, the asteroids are spread far apart. If you stood on one asteroid, the nearest neighbor might be hundreds of kilometers away. The belt is vast and mostly empty, with its countless rocks scattered thinly through space. Yet, despite this sparseness, it contains millions of objects, ranging from tiny pebbles to dwarf planets hundreds of kilometers wide. Together, they form a museum of the solar system's history. Some asteroids are rocky, made of silicate minerals like the crust of Earth. Others are metallic, rich in nickel and iron, remnants of ancient cores. Still others are dark, carbonaceous, carrying organic molecules and water locked in stone. These are the most primitive, unchanged since the solar system's birth. To scientists, such asteroids are treasure chests, preserving the chemistry of our beginnings. By studying them, we glimpse what Earth might have been made from, and perhaps how life itself was seeded. Among the belt's citizens are several giants. The largest is Ceres, nearly 1,000 kilometers wide, and so massive it is classified as a dwarf planet. Discovered in 1801 by Giuseppe Piazzi, Ceres was at first thought to be the missing planet between Mars and Jupiter. Instead, it turned out to be the first of many discoveries, opening the door to a new realm. Today, Ceres is known to contain water ice beneath its surface, and even mysterious bright spots in its craters, salty deposits left by briny water that may once have seeped up from below. For a while, NASA's Dawn spacecraft orbited Ceres, sending back images of this small, round world, proving that even in the asteroid belt, surprises abound. Another notable member is Vesta, nearly as large as Ceres but rockier, with a surface scarred by massive impacts. One such collision blasted pieces of Vesta into space, many of which eventually fell to Earth as meteorites. When scientists study these meteorites in laboratories, they hold pieces of Vesta in their hands, fragments of the belt delivered to our planet by chance. Vesta's surface reveals layers like Earth's: crust, mantle, core. It is a world that nearly became a planet but never fully did. Other asteroids, though smaller, are just as intriguing. Some, like Pallas and Hygeia, are nearly as large as Vesta. Many others are irregular, potato-shaped, tumbling end over end. Some travel in pairs, locked in mutual orbits, while others have tiny moons of their own. There are even families of asteroids, clusters born when a larger body was shattered by a collision. Over millions of years, these families drift apart but still share similar orbits, cosmic siblings tied by origin. The belt is not static. It is dynamic, restless, ever-changing. Collisions are rare given the distances, but they do occur, smashing rocks into fragments and creating dust that forms faint asteroid trails. Jupiter's gravity continues to stir the region, carving gaps known as Kirkwood gaps, where orbital resonances with the giant planet keep space relatively clear. Asteroids that stray too close to these resonances may be flung out of the belt entirely, sent spiraling inward toward Earth or outward toward the outer solar system. In this way, the asteroid belt is not just a graveyard but also a source, feeding the solar system with meteoroids and comets. And Earth knows their touch. Throughout history, asteroids from the belt have struck our planet, leaving scars visible today. The Chicxulub impact, which contributed to the extinction of the dinosaurs, likely began in the asteroid belt. Other impacts carved craters like Meteor Crater in Arizona. Though catastrophic, these collisions also shaped Earth's history, delivering metals, water, and perhaps the building blocks of life. The belt has been both our benefactor and our threat. For humanity, the asteroid belt represents opportunity as well as danger. Its rocks contain vast resources, metals like iron, nickel, and platinum, water that could be turned into fuel for spacecraft. One asteroid could hold more wealth and minerals than has ever been mined on Earth. In the future, humans may mine the belt, establishing stations among the asteroids, turning these drifting rocks into stepping stones for journeys deeper into space. Science fiction often imagines asteroid miners living in hollowed-out rocks, carving out homes in places that once drifted silently. One day, this vision may not be fiction at all. But the belt is also a place of wonder. Imagine standing on Ceres, gazing up at the sky. The sun would be smaller and dimmer than on Earth, but still bright. Jupiter might hang like a giant lantern, glowing in the distance. The stars would be sharp, unblinking. Around you would be silence, broken only by your own breath. It would feel lonely, yet also magnificent, a reminder that the universe is both vast and intimate, filled with worlds that await discovery. The discovery of the asteroid belt itself is a story of human curiosity. In the late 1700s, astronomers noticed a pattern in the spacing of planets, known as the Titius-Bode law. According to this pattern, there should be a planet between Mars and Jupiter. When none was known, astronomers began searching. Their quest was called the Celestial Police, a coordinated effort to sweep the skies. And indeed, on January 1, 1801, Giuseppe Piazzi spotted Ceres. Over the next few years, more objects were found: Pallas, Juno, Vesta. At first, they were all called planets, but as their numbers grew, astronomers realized they were something else entirely. Thus the asteroid belt entered human knowledge, a new category of celestial objects, filling the gap where a planet was expected but never formed. Since then, we have mapped thousands, tracked millions, and sent spacecraft to visit a few. NASA's Dawn explored Vesta and Ceres, while missions like OSIRIS-RX have visited near-Earth asteroids like Bennu, bringing back samples. Each mission deepens our understanding not just of asteroids themselves, but of the story of our solar system. These rocks are time capsules, preserving the raw materials of creation. To study them is to look back 4.5 billion years, to glimpse the earliest days of the sun and planets. For young explorers today, the asteroid belt is both a mystery and a promise. It reminds us that not all paths lead to planets. Sometimes, they lead to fragments, leftovers, scattered pieces that still matter deeply. It shows us that what seems like failure, a planet that never formed, can become a treasure trove of knowledge. And it hints at the future, where humanity might expand into space not by leaping directly to Jupiter or Saturn, but by slowly building a presence among the asteroids, learning to live off the resources of space itself. So when you hear the words, asteroid belt, do not think only of danger, of cinematic fields of rocks threatening starships. Think of history, frozen in stone. Think of possibility, locked in minerals and water. Think of silence, of lonely worlds circling the sun, waiting for us to notice them. The asteroid belt is a reminder that the solar system is not neat and orderly, but wild and unfinished, full of places where the story did not go as expected. And yet, those places are often the most interesting of all. In the grand story of the solar system, the asteroid belt is the chapter of fragments, pieces of a planet that never was, yet also pieces of a puzzle we are still assembling. Its rocks may be small, but its meaning is vast. It connects the fiery birth of the planets to the icy edges of the Oort cloud. It bridges the inner solar system we know with the outer giants we dream of. It carries in its stones the memory of beginnings and the promise of futures yet to come. One day, perhaps, young people will live and work among the asteroids, carving homes from rock, harvesting metals, watching the sun rise faintly over jagged horizons. For them, the belt will not be a distant idea but a home. And they will tell the story of how humanity once looked up from Earth, wondered about a missing planet, and instead found something even richer, a whole world of worlds, a belt of fragments, a treasure of history circling silently between Mars and Jupiter. The asteroid belt is not just rubble. It is a reminder that even what is broken can still shine, that even fragments can tell a story, and that sometimes the unfinished chapters are the ones worth exploring most. Imagine standing on a dark hillside thousands of years ago, no city lights to drown the stars. The sky is alive with pinpricks of light. You notice Jupiter, brighter than almost everything else, and you sense there is something different about it. It doesn't twinkle like stars do. It seems steady, solid, as if it were a lantern closer to Earth. Watching night after night, you see it move across the sky, a wanderer among the fixed stars. You might believe it to be a god watching over you, a divine presence that commands respect. For ancient cultures, Jupiter was more than a light, it was a sign of cosmic order. As centuries passed, humans studied the heavens with sharper eyes. By the time of the Renaissance, when Galileo Galilei raised his telescope to the skies in 1610, Jupiter revealed its first great secret: 4 tiny moons orbiting it. Night after night, Galileo sketched their positions. He saw them move. He realized that not everything revolved around Earth, that there were bodies circling another world. This discovery shook the foundations of thought. For a society that believed Earth was the center of the universe, Jupiter's moons whispered a new truth: we were not the center after all. Those 4 moons, Io, Europa, Ganymede, and Callisto, are now called the Galilean moons in his honor. They were the first evidence that the universe was wider, stranger, and grander than we had imagined. But Galileo had seen only the beginning of Jupiter's wonders. As technology advanced, telescopes revealed bands of clouds wrapped around its girth, swirling storms larger than Earth itself, and colors shifting like brushstrokes across a living canvas. Astronomers watched the Great Red Spot, a hurricane-like storm that had been raging for centuries, perhaps millennia. They calculated Jupiter's immense size, so massive it could swallow 1,300 Earths inside it. They realized it was not a solid world but a gas giant, a planet made mostly of hydrogen and helium, more like a failed star than a rocky planet. Jupiter, in a sense, was a reminder that not all worlds are like ours. Some are colossal, alien, and strange beyond easy comparison. To truly understand Jupiter, imagine leaving Earth on a long journey. You drift past the Moon, beyond Mars, cross the asteroid belt, and finally approach a glowing giant in the distance. At first it seems like a bright marble, striped with creams, oranges, and browns. As you draw closer, it grows until it dominates the view, a planet 11 times wider than Earth. Its surface, or what looks like a surface, is an ocean of clouds, churning endlessly, whipped by winds faster than any hurricane on Earth. The atmosphere is layered in bands, lighter zones and darker belts. These stripes are storms, currents of gas flowing east and west at tremendous speeds. Unlike Earth, Jupiter has no solid ground to stand on. The deeper you go, the thicker the gas becomes, until it transitions into liquid hydrogen, and deeper still, perhaps metallic hydrogen, swirling in ways we can scarcely imagine. Hovering in orbit, you would notice that Jupiter is not alone. Around it spins a kingdom of moons, more than 90 known today, from tiny captured asteroids to giant worlds larger than Mercury. Each moon is unique, a world unto itself. Together they form a miniature solar system orbiting their colossal master. First there is Io, closest to Jupiter, a world alive with fire. Imagine a planet where volcanoes constantly erupt, spewing fountains of sulfur into space, painting the surface in shades of yellow, red, and black. Tidal forces from Jupiter's gravity twist and squeeze Io's interior, keeping it molten and restless. To stand on Io's surface, if you could survive the radiation raining down from Jupiter, would be to witness the most volcanically active place in the solar system. Next comes Europa, one of the most intriguing worlds ever discovered. Its surface is smooth, bright, and icy, crisscrossed by dark cracks. Scientists believe beneath that frozen crust lies a vast ocean of liquid water, kept warm by tidal heating. Imagine an ocean twice the volume of all Earth's oceans combined, hidden beneath kilometers of ice, untouched for billions of years. Could life exist there? Tiny microbes, strange fish-like creatures, perhaps something beyond our imagination. Europa has become a beacon of hope in the search for extraterrestrial life, a reminder that oceans do not always need sunlight to thrive. Then there is Ganymede, the largest moon in the solar system, even bigger than Mercury. It has its own magnetic field, a rarity for moons, and a surface marked by both ancient craters and strange grooved terrain. Ganymede is not just a satellite, it is a world with complexity, with mysteries that scientists are only beginning to unravel. And beyond it, Callisto, a heavily cratered relic, its ancient surface frozen in time. Callisto is a record of billions of years of history, a world that has changed little since the early solar system. But Jupiter's domain stretches further still. Its immense gravity shapes the solar system itself. It acts as a guardian, pulling in or deflecting comets and asteroids that might otherwise threaten Earth. Some scientists believe that without Jupiter, life on Earth might have been wiped out long ago by frequent impacts. In this sense, Jupiter is both a giant neighbor and a silent protector, watching over our small blue world. As humanity's curiosity grew, we sent machines to visit this giant. In the 1970s, Pioneer and Voyager spacecraft flew past, sending back breathtaking images of Jupiter's bands and moons. Later, Galileo the spacecraft, not the man, orbited Jupiter for years, studying its atmosphere and moons up close. It even sent a probe plunging into Jupiter's clouds, measuring pressure, temperature, and winds until the crushing depth destroyed it. More recently, NASA's Juno spacecraft has been orbiting Jupiter since 2016, mapping its magnetic field, peering beneath its clouds, and capturing dazzling portraits of its poles. Juno revealed Jupiter's auroras, giant ovals of glowing light caused by particles spiraling along magnetic fields, brighter and larger than any auroras on Earth. It showed us cyclones arranged like geometric patterns at the poles, storm systems behaving like living organisms. With every discovery, Jupiter proves more complex, more astonishing, more alive than we expected. Yet Jupiter is not just a scientific wonder. For young dreamers, it is also a symbol of imagination. Writers and filmmakers have long used it as a canvas. In Arthur C. Clarke's stories, Jupiter and its moons become the stage for contact with extraterrestrial intelligence. In countless science fiction tales, colonies are imagined floating in its atmosphere, or drilling into its moons for resources, or diving into its depths with impossible machines. To think about Jupiter is to stretch the imagination, because its scale and strangeness defy the ordinary. Picture what life might be like in Jupiter's system one day. Perhaps humans build stations orbiting Ganymede or Europa, harnessing energy, exploring oceans beneath ice, searching for alien life. Perhaps robotic submarines swim through Europa's waters, sending back images of creatures adapted to eternal darkness. Maybe colonies mine the asteroids of the outer solar system, with Jupiter's gravity slingshotting ships on interplanetary journeys. Jupiter could become a hub, a crossroads of exploration. But it also reminds us of our limits. We cannot land on Jupiter as we might on Mars or the Moon. There is no solid ground, only endless clouds leading to crushing depths. To fall into Jupiter would be to descend through layers of gas until the pressure destroyed you, long before you reached any kind of core. Jupiter humbles us, showing that not every world is meant for human footprints. Some must be admired from afar, studied with instruments, respected as realms we cannot conquer. Still, even from afar, Jupiter teaches us. Its great red spot shows us storms on scales beyond comprehension. Its magnetic field, 10 times stronger than Earth's, teaches us about planetary cores and cosmic radiation. Its moons show us that even cold, distant worlds can harbor oceans and volcanic fire. Jupiter is not just a giant, it is a laboratory, a natural experiment that helps us understand the universe. Most of all, Jupiter is a reminder of perspective. To see it hanging bright in the night sky is to realize how vast our solar system is, how many kinds of worlds exist, how small Earth truly is. And yet, it is also to realize that we are capable of reaching out, of sending our minds and machines across hundreds of millions of kilometers, of learning and imagining. For young adults today, Jupiter is more than a planet. It is a challenge, a mystery, a wonder. It is a story still unfolding, one we can be part of through curiosity and exploration. So the next time you look up and see that brilliant star-like light, remember what it is. Not just a dot in the sky, but a giant world with storms the size of continents, moons that may hold oceans, and a history intertwined with our own. Jupiter is the king of planets, the guardian of Earth, the stage of myths, the frontier of science. It has inspired humanity for millennia, and it will continue to do so as long as we lift our eyes to the stars. And perhaps one day, far in the future, children living on Europa or Ganymede will look up into their skies and see Jupiter looming vast and majestic above them, its striped clouds and storms filling half the heavens. To them, Earth will be the distant world, a pale dot shining faintly. They will tell stories of how their ancestors crossed the void, how they built homes under alien skies, how they turned myths into reality. And Jupiter, the great wanderer, will stand eternal, a reminder of both our smallness and our greatness. Jupiter is not merely a planet. It is a story of gods and storms, of moons and mysteries, of protection and power. It is the story of our search for meaning in the universe, our hunger to explore, our willingness to dream beyond what seems possible. And as long as we dream, Jupiter will remain not only the king of planets, but a beacon of human imagination, forever shining in the night sky. When you first look up at Saturn through even a modest telescope, it feels like a secret has been revealed. You see not just a bright dot in the sky but a tiny world crowned with shimmering rings. It seems almost unreal, as though the universe itself had tried its hand at jewelry. To the naked eye, Saturn is a pale, steady light wandering among the stars, but once magnified, it becomes something so breathtaking that many astronomers have described it as the most beautiful sight in the heavens. And perhaps that is Saturn's gift to humanity, to remind us that the cosmos can surprise us with beauty, not only with mystery or terror. But Saturn's story is not just about rings of ice and dust. It is about myths that cast it as a devourer of children, about centuries of human wonder, about spacecraft that sailed through its orbit like explorers charting seas, and about moons that may hold oceans where life could stir. Saturn is a planet of contrasts, serene in its appearance, but violent in its storms, ancient in myth, but futuristic in its scientific promise. It is both a symbol and a destination, a puzzle and a poem. Long before telescopes, ancient people noticed Saturn wandering across the sky more slowly than the other bright planets. While Mercury darted quickly and Jupiter strode with confidence, Saturn lingered, taking nearly 30 years to complete a journey around the Sun. To the Babylonians, this slowness linked it with Ninurta, a god of agriculture and time. The Greeks called it Kronos, ruler of the Titans, associated with time itself and with harvest. The Romans adopted this name as Saturnus, a god of wealth and renewal but also a darker figure, who in myth devoured his children for fear of being overthrown. Saturn thus became both a symbol of abundance and a symbol of limitation, of time's inevitable march and the cycle of life and death. Imagine yourself as an ancient sky watcher, tracing Saturn's position year after year, watching it inch its way across constellations. Its slow dance made it feel distant, heavy, deliberate, different from the quick lights of other planets. To them, Saturn was not a fiery god like Mars or a benevolent king like Jupiter. It was older, wiser, slower, tinged with melancholy. Even now, astrologers speak of Saturn as the planet of discipline, restriction, and endurance, a reflection of how deeply its slow journey imprinted on human imagination. Then came the telescope. In 1610, Galileo Galilei pointed his homemade instrument at Saturn and saw something that baffled him. To his eyes, Saturn seemed to have two large ears on either side, or perhaps three bodies close together. He sketched what he saw but admitted confusion. A few decades later, Dutch astronomer Christiaan Huygens used a more powerful telescope and finally solved the riddle. Saturn was surrounded by a thin, flat ring. A ring that did not touch the planet, but encircled it like a halo. It was unlike anything else in the sky. With that discovery, Saturn's reputation as the most enchanting planet in our solar system was cemented forever. The rings became a symbol of mystery. What were they made of? Were they solid, like a great disk? Were they liquid? Or were they countless particles orbiting Saturn, like a swarm of icy bees around a hive? Over centuries, scientists learned the truth. Saturn's rings are made mostly of ice, with some dust and rock, ranging in size from grains smaller than sand to chunks as large as mountains. They stretch tens of thousands of kilometers across, but they are astonishingly thin, often no thicker than a kilometer. Imagine a sheet of paper spread over a football field. That is the kind of scale we are talking about. Something vast yet delicate, immense yet fragile. If you could hover above Saturn, the view would be beyond words. Below, the planet itself would loom, 9 times wider than Earth, a giant sphere striped with golden hues. Swirling storms and cloud bands streak its atmosphere, driven by winds faster than any hurricane on Earth. Saturn, like Jupiter, is a gas giant, made mostly of hydrogen and helium, with no solid ground to stand on. Falling into Saturn would be like falling into endless clouds, crushed long before reaching any kind of core. Above it all, the rings would stretch outward, shimmering, glowing in sunlight, thin as smoke but wide as worlds. And Saturn is not alone. Orbiting it are more than 80 moons, each one a world with its own character. They are the true jewels of the Saturnian system. The largest is Titan, bigger than Mercury, cloaked in a thick orange atmosphere of nitrogen and methane. On Titan, rivers and lakes of liquid methane and ethane carve the landscape, and methane rains fall from the sky. Imagine walking on Titan with a protective suit. The horizon would be hazy, the ground spongy, and in the distance, liquid seas would lap against icy shores. Some scientists dream of sailing those alien seas with robotic submarines, exploring a world where chemistry may mimic the beginnings of life itself. Then there is Enceladus, a small moon that shines bright and white like a pearl. For years it seemed unremarkable, until the Cassini spacecraft flew by and discovered geysers erupting from its south pole, jets of water vapor and ice shooting into space. Beneath Enceladus' icy crust lies a global ocean of liquid water, warmed by tidal forces. In that ocean, with heat, water, and organic molecules, the ingredients for life may exist. Cassini even flew through the plumes, tasting their chemistry, finding hints of complex organic compounds. Suddenly, Enceladus became one of the most exciting places in the solar system for the search for life. Other moons tell other stories. Mimas, with a giant crater, looks eerily like the Death Star from science fiction. Iapetus has one side dark as coal and the other bright as snow, as if painted in halves. Rhea, Dione, Tethys, each a frozen relic, a worldlet orbiting its giant parent. Together, Saturn and its moons form a miniature solar system, diverse and rich, a cosmic family circling the ringed giant. For centuries, Saturn was admired from afar. Then came the age of spacecraft. In the late 20th century, Pioneer and Voyager missions flew past, capturing the first close-up views of its rings and moons. But it was the Cassini-Huygens mission, launched in 1997, that truly unveiled Saturn's wonders. Cassini orbited Saturn for 13 years, sending back breathtaking images and data. It revealed the structure of the rings, the weather patterns of Saturn's atmosphere, the geysers of Enceladus, and the methane seas of Titan. In 2005, the Huygens probe detached from Cassini and parachuted through Titan's atmosphere, landing softly on its surface, the first and only time a spacecraft has touched down on a world in the outer solar system. For a few hours, it sent back pictures of an alien landscape of rounded ice pebbles and misty skies, a glimpse of a world both strange and strangely familiar. Cassini's journey ended in 2017 when it dove into Saturn's atmosphere, burning up like a shooting star. Scientists chose this fiery end to avoid the risk of contaminating Enceladus or Titan with earthly microbes. As it fell, Cassini sent back precious final data, a farewell to a mission that transformed our understanding. For many, it felt like saying goodbye to a trusted explorer, a companion who had shown us wonders we never expected. Saturn's story is not just science, it is also inspiration. Writers and artists have imagined it for centuries. Science fiction often portrays Saturn as a backdrop for colonies, research stations, or mysterious encounters. The beauty of the rings makes it the ultimate stage for imagination. You can picture future travelers orbiting Saturn, gazing out of windows as the rings glow in starlight, feeling that mix of awe and humility that Saturn inspires. Perhaps one day, humans will build habitats on Titan, sailing its methane lakes. Perhaps they will send submarines to explore Enceladus' hidden ocean, searching for signs of alien life. Saturn will not be a place we walk upon, it has no ground, but it may become a place we live near, explore, and learn from. What Saturn teaches us, perhaps more than any other planet, is balance. Its rings remind us of fragility. They may not last forever. Scientists believe they are temporary on cosmic time scales, perhaps only a few 100 million years old. And they may disappear in another 100 million. Imagine Earth's entire history compressed into one day. Saturn's rings might last only a few minutes of that day. We are lucky to live at a time when the rings exist, when we can see and marvel at them. They are a cosmic gift, a fleeting beauty. Saturn also teaches us about time, just as ancient people sensed. It takes Saturn nearly 30 Earth years to complete one orbit around the Sun. That means if you were born when Saturn was in one part of the sky, it won't return to that position until you are 30 years old. Astronomers call this the Saturn return, and some see it as a symbolic milestone in life, when maturity, responsibility, and change arrive. In this way, Saturn has always been linked to the rhythm of life, to cycles, to patience. For young dreamers today, Saturn is a reminder of wonder. It is proof that the universe contains beauty beyond utility, that some things exist not just to be understood, but to be admired. To see Saturn is to feel the scale of the cosmos, to realize we are small but also capable of grasping vastness. Saturn humbles us, but it also lifts us. So when you next look up at the night sky and find Saturn, a steady, golden point, remember what it hides. A giant of gas and storms. Rings of icy particles that stretch wider than Earth itself. Moons with oceans and seas, with mysteries waiting to be uncovered. Remember the myths of Kronos and Saturnus, the stories of time and endings, but also of harvest and renewal. Remember the spacecraft that have visited, the images that showed us beauty beyond words. And remember that Saturn is not just out there, it is part of our story, part of our human journey to know, to explore, to dream. Perhaps one day, centuries from now, children will grow up on Titan under orange skies, or swim in oceans beneath Enceladus ice, or study the rings from orbiting stations. For them, Saturn will not be a distant light but a home, a familiar neighbor. And Earth will be the pale blue dot they look at with wonder, telling stories of where humanity began. Saturn is more than a planet. It is a symbol of beauty, fragility, and time. It is a reminder that the universe is not only violent or cold but also adorned with splendor. It is a challenge to explore, a mystery to solve, and a gift to cherish while it lasts. Among all the worlds in our solar system, Saturn is the one that teaches us to pause, to marvel, to recognize that sometimes the universe creates art. And as long as we keep looking up, Saturn will continue to inspire us, not just as the ringed planet, but as a timeless beacon of wonder in the grand story of the cosmos. If Saturn is the planet that dazzles with beauty, and Jupiter is the planet that commands with size, then Uranus is the planet that surprises. For centuries it hid in plain sight, faintly glowing in the night sky, overlooked as just another star. Only when humanity sharpened its tools and widened its curiosity did Uranus reveal itself as a world, an ice giant, a planet turned sideways, a place that defies expectations. In many ways, Uranus is the forgotten planet, less famous than Jupiter or Saturn, less visited than Mars, less romantic than Venus. Yet its story is one of mystery and wonder, and for those willing to listen, Uranus has much to teach about exploration, humility, and the unknown. Imagine standing beneath the stars in the late 1700s. The telescope has been invented for more than a century, and astronomers across Europe are scanning the skies with lenses polished to perfection. One such astronomer is William Herschel, a musician turned stargazer, who in 1781 looked through his telescope and noticed something unusual. He thought at first it was a comet, an object moving slowly against the fixed background of stars. But night after night, as he tracked it, he realized it was no comet. It was a planet. For the first time in recorded history, a new planet had been discovered beyond those known to ancient civilizations. Think of what that meant. Until then, humanity believed the solar system ended with Saturn. Herschel's discovery doubled the known size of our celestial neighborhood. The universe suddenly seemed much larger, much more open than anyone had dared to imagine. He named the planet Georgium Sidus, after King George III of England, hoping to gain royal favor. But other astronomers disliked such blatant flattery. Eventually, the planet was renamed Uranus, after the ancient Greek god of the sky, father of Saturn, Kronos, and grandfather of Jupiter, Zeus. It was fitting. Uranus was the sky god, the vast expanse above, a symbol of the unknown. But Uranus did not just surprise humanity by existing. Its very nature is peculiar. Most planets spin upright or with a modest tilt, like Earth's 23.5 degrees, giving us our seasons. Uranus, however, lies on its side, tilted at an astonishing 98 degrees. Imagine rolling a ball on the floor with a stick stuck through its center. Uranus spins like that ball, rotating almost horizontally. This means its poles take turns facing the sun directly. For nearly half a Uranian year, 42 Earth years, one pole basks in sunlight while the other is plunged into darkness. Then the cycle flips. The seasons of Uranus are unlike anything else in the solar system. A single day still lasts about 17 hours, but its years stretch to 84 Earth years. If you were born on Uranus, you might not live to see a full Uranian year. What caused this tilt? Scientists are not entirely sure. Some suspect that long ago, Uranus was struck by a massive object, perhaps the size of Earth, knocking it onto its side. Others think gravitational interactions with neighboring planets twisted its orientation. Whatever the cause, Uranus became a cosmic oddball, a planet unlike any other. Approach Uranus in your imagination. From afar, it looks like a pale blue-green marble, smooth and serene, almost featureless. This color comes from methane in its atmosphere, which absorbs red light and reflects blue and green. Unlike Jupiter and Saturn, with their swirling stripes and storms, Uranus seems calm, quiet, modest. But appearances deceive. Beneath that calm lies complexity. Its atmosphere contains hydrogen, helium, and methane, but deeper down, pressures rise, and temperatures soar. Scientists believe that Uranus, along with its twin Neptune, belongs to a unique class of planets called ice giants, worlds dominated not by gas alone, but by ices, water, ammonia, methane in exotic forms. Within Uranus' interior may exist oceans of water mixed with ammonia, perhaps layers of superheated ice behaving more like a strange, slushy solid. Even stranger, Uranus' magnetic field is tilted and off-center, unlike Earth's neat alignment with its core. Its magnetosphere is lopsided, unpredictable, flickering with auroras that dance not just at the poles but in unexpected places. It is as if Uranus refuses to conform, bending the rules of planetary behavior. And Uranus is not alone. Orbiting it are 27 known moons, each named not after gods, like the moons of other planets, but after characters from English literature, Shakespeare and Alexander Pope. There is Miranda, a small moon scarred by cliffs and canyons that seem stitched together from mismatched pieces, as if it were shattered and reassembled. There is Ariel, bright and icy, crossed by valleys and ridges. Umbriel, darker and gloomier. Titania and Oberon, the largest, named after the fairy king and queen in A Midsummer Night's Dream. Each moon is a frozen world, a story in itself, circling the tilted giant. And then there are the rings. Yes, Uranus has rings, 13 known so far, thin and faint, discovered in 1977 when astronomers watched a star blink as Uranus passed in front of it. These rings are dark, made of icy particles mixed with dust, less grand than Saturn's shimmering bands but remarkable nonetheless. They circle the planet like scars, evidence of collisions or shattered moons. Uranus, it seems, carries its history visibly, though subtly. Despite its importance, Uranus remains one of the least explored planets. Only one spacecraft has ever visited, Voyager 2, which flew by in 1986. It gave us the first close-up images of Uranus, revealing its pale blue face, its moons, its rings. But the encounter was brief, a mere passing glance on a long journey outward. Since then, Uranus has been left alone, studied only from afar by telescopes. It is a giant world, yet one we know less about than Mars or even Pluto. It waits, patient, tilted in silence, for us to return. Still, Uranus has a way of shaping human thought. When it was discovered, it expanded the solar system and sparked the hunt for more. Astronomers soon noticed that Uranus did not move exactly as predicted by Newton's laws. It seemed to wobble, as if tugged by something unseen. That led to the discovery of Neptune in 1846, a triumph of mathematics and observation. Uranus, in a sense, gave birth to Neptune, proving that careful study of one planet can reveal the existence of another. But beyond science, Uranus inspires imagination. Writers have pictured explorers drifting past its rings, colonists building stations on its moons, adventurers diving into its icy clouds. Because Uranus is distant, cold, and strange, it becomes a canvas for creativity. How would humans live with 42 years of sunlight and 42 years of night? What mysteries might its tilted magnetosphere hold? Could its moons hide underground oceans like Europa or Enceladus, waiting for discovery? Uranus is a world of questions, and questions are the spark of stories. Picture life near Uranus in the far future. Perhaps humans build orbiting stations, harvesting energy from the planet's magnetic fields, mining its moons for resources. Imagine looking out a window and seeing Uranus filling the sky, glowing turquoise, its rings faintly visible, its moons drifting like lanterns. You might stand on Miranda's jagged cliffs, staring at a horizon carved by ancient chaos. Or fly a probe through the upper atmosphere, tasting the chemistry of methane clouds. Uranus could become not just a point of light, but a frontier of discovery. Yet it is also a reminder of humility. For all our technology, we still know so little. Uranus' interior remains a mystery. Its weather is not fully understood. Its moons are only roughly mapped. To study Uranus deeply will require new missions, new explorers, new curiosity. It waits, silent and strange, challenging us to keep reaching outward. And perhaps that is Uranus' greatest gift. It teaches us that the universe is larger than we expect, stranger than we assume, and more surprising than we imagine. Herschel thought he saw a comet, but it was a planet. We thought it was calm, but it hides storms and mysteries. We thought the solar system ended with Saturn, but Uranus opened the door to Neptune, Pluto, and beyond. Uranus is the planet of surprises, the reminder that discovery often begins when we look again at what we thought we already knew. So the next time you see Uranus, faint, distant, requiring effort to find, remember what it represents. A planet that expanded our world. A planet that spins on its side. A planet with rings, moons, storms, and secrets. Remember Herschel's astonishment, the thrill of Voyager's flyby, the promise of future missions. And remember that in exploration, as in life, some of the greatest discoveries are those hiding in plain sight, waiting for us to notice. Perhaps one day, young explorers will grow up orbiting Uranus, studying its tilted seasons, mapping its icy moons. For them, Earth will be a distant blue dot, the place their ancestors came from. They will tell stories of how Uranus was once a faint star, overlooked, until someone dared to look closer. And Uranus, the sideways world, will stand as proof that the universe always has more to show. Uranus is not merely a planet. It is a lesson in curiosity, a reminder of humility, a promise of surprise. It shows us that the cosmos is not finished revealing itself. And as long as we keep looking, as long as we keep asking, as long as we keep exploring, Uranus will remain a beacon of discovery in the grand adventure of the human story. If Uranus is the planet of surprises, then Neptune is the planet of whispers, distant, elusive, and almost invisible to the naked eye, but carrying with it the power to change our understanding of the universe. To know Neptune is to know the story of patience, persistence, and the triumph of human curiosity. It is the last of the great planets, the farthest giant in our solar system, the end of the known before the mysteries of the Kuiper belt and the scattered disk. Neptune is not just another world, it is a symbol of how imagination, mathematics, and observation can come together to reveal something that was always there, waiting for us to notice. Imagine standing in the 1800s, long after William Herschel discovered Uranus in 1781. Astronomers were still marveling at this new addition to the solar system. But as they tracked Uranus' path across the sky, something strange emerged. Uranus was not behaving exactly as predicted. Its orbit seemed off, tugged this way and that by some invisible hand. Was it just a mistake in the calculations, or was there something else out there, something massive, exerting its pull? Two men, working independently, tried to solve this mystery, John Couch Adams in England and Urbain Le Verrier in France. With nothing but paper, ink, and mathematics, they calculated where a hidden planet might be. It was one of the boldest predictions in science, that a world no one had ever seen existed, and they could tell where it was simply by the way it tugged on Uranus. In 1846, Johann Galle at the Berlin Observatory pointed his telescope to the spot Le Verrier had suggested. And there it was, Neptune, shining faintly in the night sky. A planet discovered not by accident, not by myth, not by luck, but by the power of reason. For the first time in history, a new planet was found through mathematics before it was ever seen by human eyes. Neptune became a triumph of science, a reminder that the universe follows patterns we can discover if we are determined enough to look. And what a world it turned out to be. From Earth, Neptune looks like a tiny blue dot, but up close it is a majestic giant, slightly smaller than Uranus but far more dynamic. Its brilliant sapphire color comes from methane in its atmosphere, absorbing red light and reflecting blue, but its particular shade is deeper, richer, as if the universe painted it with the darkest ocean hues. To gaze at Neptune is to look into a cosmic sea, cold and endless. Neptune lies about 4.5 billion kilometers from the Sun, so far that sunlight takes more than 4 hours to reach it. A year on Neptune lasts 165 Earth years. Imagine celebrating your first birthday there. You'd be older than most civilizations before you'd complete one orbit. A day, however, is swift, just 16 hours. Its seasons, like those of Uranus, last for decades, though Neptune's tilt is more familiar, at 28 degrees. Approach Neptune in your mind's eye. Unlike the calm face of Uranus, Neptune is alive with weather. Voyager 2, the only spacecraft ever to visit, revealed towering storms larger than Earth itself. The Great Dark Spot, seen in 1989, was a vast storm system with winds whipping faster than any other in the solar system, up to 2,100 kilometers per hour. Imagine standing in that gale, winds so fierce they would shred metal, sweeping through icy methane clouds. Neptune is a world of extremes, a reminder that even in the distant reaches of the solar system, chaos and energy thrive. What drives such storms so far from the Sun, where little heat reaches? Scientists believe Neptune has an internal heat source, radiating more energy than it receives. Deep within, pressures and temperatures may create exotic states of matter, superionic water ice, where molecules behave strangely, conducting electricity while remaining solid. Neptune and Uranus are the ice giants, a category distinct from the gas giants Jupiter and Saturn. Beneath Neptune's swirling clouds lies a mantle of water, ammonia, and methane ices, dense and turbulent, surrounding a rocky core. It is a world that defies the simple categories of rocky or gassy. And Neptune, like Uranus, has a magnetic field that is oddly tilted and off-center, making its magnetosphere twist and flicker unpredictably. If you could orbit Neptune in a ship, you would see auroras shimmering not neatly at the poles but scattered, dancing unpredictably across its skies. Neptune also wears rings, faint, dusty arcs discovered in the 1980s. Unlike Saturn's grand displays, Neptune's rings are subtle, dark bands circling the planet. Some of them form clumps, called ring arcs, held together by the gravity of tiny nearby moons. These fragile structures remind us that beauty is not always bold, sometimes it is delicate, hidden, revealed only to those who look carefully. But perhaps the greatest wonders of Neptune lie in its moons. 13 are known, the largest being Triton, a world that breaks almost every rule. Triton is unique among large moons because it orbits Neptune backward, in what astronomers call a retrograde orbit. This means it did not form alongside Neptune but was likely captured long ago, perhaps a wandering object from the Kuiper belt. Triton is big, larger than Pluto, and geologically active. When Voyager 2 flew past, it saw geysers spewing nitrogen gas into space, driven by sunlight warming the icy surface. Imagine walking on Triton, a frozen landscape of nitrogen ice, pinkish and ridged, with plumes erupting kilometers high. It is one of the few moons in the solar system known to be active today. Triton's future is dramatic. Slowly, inevitably, it is spiraling inward toward Neptune. One day, millions of years from now, it will cross the boundary where tidal forces tear it apart. Triton may become a magnificent ring system, more glorious than Saturn's, encircling Neptune like a crown of ice and dust. The cosmos is never still, even moons dance toward destruction and rebirth. And yet, Neptune remains distant, mysterious. Voyager 2's brief flyby in 1989 is still our only close encounter. That mission gave us glimpses, a storm, a few moons, a sense of Neptune's restless energy, but it left countless questions. What lies deep in its mantle? How do its storms form and vanish? What secrets does Triton hold beneath its frozen crust? Could it, like Europa or Enceladus, hide an underground ocean, a place where life might exist in the dark? Astronomers dream of returning. Proposals exist for orbiters, probes that could study Neptune and Triton in detail, mapping their surfaces, diving into their atmospheres, searching for answers. But Neptune's distance makes such missions difficult, requiring decades of travel and immense resources. For now, Neptune waits, a blue jewel at the edge of our solar system, whispering its mysteries into the void. Yet Neptune is more than storms and moons. It is a turning point in human thought. Its discovery through mathematics proved that the universe could be understood not just through myth or observation but through prediction, calculation, imagination. It showed us that the cosmos follows patterns, and if we are clever enough, we can find them. Neptune is a planet born not of chance but of intellect, a monument to the human mind's ability to reach across billions of kilometers and say, "There it is." Picture the far future. Perhaps ships will one day orbit Neptune, their windows glowing against the cold, their crews gazing at the deepest blue imaginable. Perhaps colonies will dot Triton's surface, domes heated against the cold, geysers erupting in the distance. Imagine children growing up there, learning that their home was once just a faint star, invisible to the ancients, discovered by numbers on a page. They will celebrate Neptune as not just a planet but a triumph of curiosity. Neptune's story, then, is not just about a planet. It is about us. About how we look at the universe, how we refuse to stop asking questions, how we follow tiny hints, a wobble in Uranus, a strange pull, and uncover entire worlds. Neptune is a reminder that discovery is not always easy, not always obvious. Sometimes it requires patience, persistence, faith in the unseen. Sometimes it requires listening to whispers. So when you think of Neptune, think of a dark, distant giant with storms that rage faster than sound, with a moon that orbits backward and geysers that spout from frozen plains. Think of faint rings and tilted magnetic fields, of mysteries hidden in blue. But also think of the astronomers who dared to trust their equations, who believed that what they could not see might still exist. Think of Neptune as proof that the universe is knowable, but also humbling, reminding us that even now, with all our knowledge, we have only just begun to understand. Neptune is the edge of the familiar, the last of the great planets, the doorway to the unknown beyond. It is the final guardian before the Kuiper Belt, before Pluto, before the vastness of interstellar space. It stands as a symbol of limits, and of what happens when we push past them. To tell Neptune's story is to tell the story of reaching farther than we thought possible. And one day, perhaps, when humans stand on Triton's icy plains or orbit Neptune in stations that circle its rings, they will look back at Earth, a faint blue star in the distance, and smile. They will remember that their ancestors once gazed at Uranus wobble and guessed there was more, and they will know they are part of that same story of curiosity and courage. Neptune will no longer be just a point of light, or even a mysterious blue world. It will be home, frontier, and inspiration. Neptune, the whispering planet, teaches us that the universe does not give up its secrets easily. But if we listen, if we calculate, if we dare to imagine, we can uncover wonders beyond measure. Neptune waits for us, and its story is far from finished. If Neptune is the last of the great planets, then Pluto is the beginning of something else, the gateway to the unknown, the frontier where the solar system's neat order gives way to a realm of icy wanderers and frozen relics. For most of the 20th century, Pluto was called the ninth planet, the tiny outpost on the edge of the solar system. Children memorized it in rhymes, textbooks listed it alongside giants far larger, and astronomers debated its odd path across the sky. But Pluto has always been more than a label. It is a story of discovery, imagination, controversy, and ultimately humility, a reminder that the universe does not conform to our categories, but instead invites us to expand our understanding. The story begins with a search. After Uranus was discovered in 1781 and Neptune in 1846, astronomers wondered, was there yet another planet tugging at their orbits? Tiny irregularities in Neptune's path suggested there might be. In the early 1900s, Percival Lowell, an American astronomer, launched a hunt for what he called Planet X. Lowell was already famous for claiming that Mars had canals built by intelligent beings, a claim we now know was illusion, but his obsession with unseen worlds drove him forward. At his observatory in Arizona, Lowell and his team photographed the night sky, searching for anything that moved. He died without finding Planet X, but his dream lingered. In 1930, a young man named Clyde Tombaugh, only 24 years old, working at Lowell Observatory, compared pairs of photographs through a device called a blink comparator. He looked for dots of light that shifted slightly between images, signs of movement against the background of fixed stars. Night after night, he stared, patient and methodical. And then, he saw it, a tiny speck moving slowly across the sky. Planet X had been found, or so it seemed. The world rejoiced. Newspapers declared the discovery of a ninth planet. Children born in that era grew up believing the solar system stretched from Mercury to Pluto, 9 planets in a tidy sequence. Pluto, the name chosen after suggestions poured in from around the world, came from an 11-year-old girl in England, Venetia Burney, who suggested the Roman god of the underworld, fitting for a dark, distant world. It also conveniently honored Percival Lowell, with the initials PL hidden inside. Pluto was welcomed into the family of planets, the mysterious baby brother at the far edge. But Pluto was strange from the start. Its orbit is elongated, sometimes bringing it closer to the Sun than Neptune. It is tilted compared to the other planets, as if it did not quite belong to their orderly dance. And it was small, very small. At first, astronomers hoped it might be as massive as Earth, enough to explain Neptune's orbital quirks. But as decades passed and measurements improved, Pluto shrank in status. Estimates dropped from Earth-sized to Moon-sized. By the late 20th century, it was clear, Pluto was tiny, smaller even than Earth's moon, far too small to tug Neptune. In fact, the irregularities that inspired the search for Planet X turned out to be errors in observation. Pluto's discovery had been, in a sense, an accident. Still, Pluto captured imagination. For generations, it symbolized the frontier, the last stop before the stars. Science fiction writers placed bases on its frozen plains, astronomers speculated about its icy surface, and children dreamed of explorers planting flags there. Pluto was far away, so far that even light took hours to reach it, but it felt like ours, part of our solar system story. Then came the 1990s, and everything changed. In 1992, astronomers discovered another small icy body beyond Neptune, orbiting the Sun. Then another, and another. A whole new region of the solar system came into view, the Kuiper Belt, a vast ring of icy worlds, stretching beyond Neptune like a second asteroid belt, but larger and more mysterious. Suddenly, Pluto was not alone. It was one among many. And some of these new discoveries rivaled Pluto in size. In 2005, astronomers found Eris, an object even larger than Pluto. The question was unavoidable: if Pluto is a planet, shouldn't Eris be too? And if Eris, what about all the others? Were we going to call dozens of icy objects planets? The debate raged. Some defended Pluto's planetary status fiercely. It had been a planet for 76 years, after all, and many felt attached to it. Others argued that science should be based on nature, not nostalgia. In 2006, the International Astronomical Union, IAU, voted on a definition of planet. To be a planet, an object must orbit the Sun, be spherical from its own gravity, and have cleared its neighborhood of other objects. Pluto fit the first two, but not the third. It shared its space with other Kuiper Belt objects. And so Pluto was reclassified as a dwarf planet. The world reacted with shock and sadness. Children protested. Headlines declared Pluto demoted. Some saw it as cold, even cruel. But others saw it as progress, an expansion of knowledge, a recognition that our solar system is richer and more complex than we thought. Pluto had not been diminished. Instead, it had been placed in its true context, as the first known member of an entire new region of the solar system. But what exactly is this Kuiper belt? Imagine standing at Neptune's orbit and looking outward. Beyond lies a realm of icy debris left over from the birth of the solar system. These are the building blocks that never coalesced into a planet, frozen for billions of years. The Kuiper belt stretches from about 30 to 50 astronomical units, AU, from the Sun. That's 30 to 50 times the distance between Earth and the Sun. It contains countless objects, comets, dwarf planets, and icy bodies, from a few kilometers across to thousands. Pluto, Eris, Haumea, Makemake, all are part of this population. Some are round, others irregular, many with moons of their own. It is a frozen museum of the early solar system, a place where the past has been preserved in ice. Pluto itself is extraordinary. When NASA's New Horizons spacecraft flew by in 2015, the first and only mission to visit Pluto, it revealed a world far more complex than anyone expected. Pluto has mountains of water ice as tall as the Rockies, plains of nitrogen ice that flow like glaciers, and a heart-shaped region called Tombaugh Regio, named after its discoverer. Within that heart lies Sputnik Planitia, a vast basin of nitrogen ice with convection cells slowly churning, reshaping the surface. Pluto has a thin atmosphere of nitrogen, hazy and layered, that escapes slowly into space. It even has weather, with winds and possibly seasonal snows. Pluto is not dead. It is geologically active, defying expectations that small, cold worlds should be frozen and still. Something keeps its surface young, its plains smooth, its mountains sharp. Perhaps heat from radioactive elements inside, perhaps interactions with its large moon Charon. Speaking of Charon, it is half the size of Pluto itself, so large that Pluto and Charon orbit a point in space between them. They are a double world, locked in a cosmic dance, always showing the same face to each other. Imagine standing on Pluto, looking up to see Charon looming large in the sky, never moving, always present. And Pluto has other moons too, tiny ones named Nix, Hydra, Kerberos, and Styx, tumbling chaotically, irregular and small. The Pluto system is like a miniature solar system, a family of worlds orbiting together in the Kuiper belt. But the Kuiper belt extends far beyond Pluto. It is the source of short-period comets, icy travelers that occasionally fall inward, leaving glowing tails across Earth's skies. It may hide objects even larger than Pluto, worlds we have not yet found. Beyond the Kuiper belt lies the scattered disk and, farther still, the hypothetical Oort cloud, a vast sphere of icy bodies that may encircle the Sun at distances so great they defy imagination. Pluto is just the beginning of this frontier, the doorway to an unexplored wilderness. For young dreamers, Pluto's story carries a powerful lesson. Once, we thought the solar system ended with Neptune. Then Pluto expanded it. Later, we thought Pluto was unique. Then the Kuiper belt revealed a multitude. The truth is always bigger, stranger, richer than we first believe. Pluto's demotion was not an end, but an opening. It turned one lonely world into the ambassador of thousands, a reminder that discovery is never about shrinking the universe, but about expanding our view of it. Picture the far future. Perhaps ships will one day venture into the Kuiper belt, hopping from world to world, studying their icy surfaces, mining their resources, searching for clues about the solar system's origins. Colonies might grow on Pluto, domes rising over nitrogen plains, Charon's looming face visible in the eternal sky. Children there will not think of Pluto as demoted. To them, it will be home, gateway, and heritage. And perhaps, farther still, explorers will reach the scattered disk and the Oort cloud, venturing toward interstellar space, carrying with them the lesson Pluto taught, that the universe does not end where we expect. Every time we draw a boundary, discovery pushes it farther. Every time we think we know the whole, a new region opens. Pluto and the Kuiper Belt are proof that the cosmos always has more to give. So remember Pluto not as the planet that was lost, but as the world that showed us we had more to find. Remember the excitement of Clyde Tombaugh's discovery, the courage of New Horizons' journey, the beauty of a heart-shaped glacier on a tiny, frozen world. Remember that the Kuiper Belt stretches outward like an ocean of ice, filled with worlds we have yet to name. Pluto, the little wanderer, stands at the edge of the known and points us outward, whispering that the story of the solar system is far from finished. And the Kuiper Belt, vast and silent, waits for us to listen, to travel, to discover. For young explorers of today, it is a promise that beyond the familiar lies the extraordinary, waiting for eyes brave enough to see it. From the blazing heart of the sun to the icy edges where comets wander in silence, the solar system is a vast family of worlds bound together by gravity and time. Each planet, moon, and fragment of rock carries its own story, written in craters, atmospheres, and orbits. Mercury races close to the sun, scarred by ancient impacts. Venus blazes bright in our skies, a mirror of beauty that hides a world of fire. Earth thrives as a living planet, its oceans and forests humming with life. Mars waits, a red desert whispering of rivers long gone. Beyond them, the giant planets rule with storms and moons of their own, Jupiter, Saturn, Uranus, Neptune, each with secrets that remind us how many shapes a world can take. And still farther lie the dwarf planets and icy comets, remnants of creation, keeping the earliest memories of the solar system frozen in their hearts. To explore this system is to look backward and forward at once. Backward, because the craters and scars tell of a time when the sun was young, when planets collided, when life was only a possibility. Forward, because in studying these worlds we also glimpse our own future, what Earth might become, what dangers we face, and what paths might carry us to the stars. The solar system is a laboratory, a gallery, a library of stone and gas where the history of worlds can be read. And it is also our home. We are children of the sun, born of its light and nourished by the elements forged in ancient stars. The iron in our blood, the oxygen in our lungs, the calcium in our bones, all were born in stellar furnaces, scattered into space, and gathered here to form a world that could live and dream. When we look at the planets, we are not just gazing at distant orbs of rock and gas, we are looking at family, at companions who have circled the sun alongside us for billions of years. Yet the solar system is not static. It moves, it evolves, it changes. Orbits shift, asteroids wander, comets blaze and vanish. The sun itself will one day exhaust its fuel, swell into a red giant, and reshape its family forever. The story is ongoing, written in motions that stretch across billions of years. And we, for a brief moment, are here to witness it. Perhaps one day we will leave Earth and settle on other worlds. We may walk on Mars, sail the subsurface oceans of Europa, or build floating cities in the skies of Venus. We may even send ships beyond the Kuiper Belt into the interstellar dark. But wherever we go, we will carry with us the memory of the solar system, the warmth of the sun, the brilliance of Venus, the resilience of Earth, the mystery of the outer planets. This is where our story began, and it will always be part of us. So let us look upward with wonder. Let us remember that the solar system is not just a collection of rocks and gases, but a story of fire and ice, chaos and harmony, destruction and creation. It is a story that continues to unfold with every orbit, every eclipse, every comet that blazes across the night sky. And it invites us, always, to be part of it. In the end, the solar system is more than a place. It is a reminder that we are connected to the stars, to the planets, to the vast cosmos beyond. To tell its story is to tell our own, for we are stardust shaped into beings who can wonder, imagine, and explore. The solar system is our first frontier, our ancient home, and our bridge to the universe.